Good day, class. So in this video, we will differentiate several trigonometric functions. These examples involve composite functions, so we will mainly use the chain rule. But before we start, let's briefly recall an important rule. The chain rule states that if a function is inside another function, we differentiate the outer function first, and then multiply by the derivative of the inner function. Mathematically, if we have y is equal to f of g of x, then the derivative is dy over dx is equal to f prime g of x times g prime of x. So this rule will be used repeatedly in the following examples. The first function is y is equal to 6 cos times the quantity of 1 minus 3 over 2x. First, we observe the cosine is outer the function, and the expression 1 minus 3 over 2x is the inner function. So our step 1 is to differentiate the cosine function. The derivative of cos u is negative sine u. So we have y prime is equal to 6 times the quantity of negative sine times the quantity of 1 minus 3 over 2x. So our step 2 is to differentiate the inner function. The derivative, our inner function is 1 minus 3 over 2x. So the derivative of this function is simply negative 3 over 2. Now, our step 3 is to multiply them together. Y prime is equal to 6 times the quantity of negative sine times the quantity of 1 minus 3 over 2x and times the quantity of negative 3 over 2. Now, we simplify 6 times 3 over 2 is equal to 9. So the final derivative becomes y prime is equal to 9 sine times the quantity of 1 minus 3 over 2x. So that is the derivative of the first function. The second function is y is equal to 4 sine times x cubed. Again, this is a composition of functions. The outer function is sine and the inner function is x cubed. So our first step is to differentiate the sine functions. Again, the derivative of sine u is cos u. So we get y prime is equal to 4 cos times x cubed. Then differentiate the inner function. The derivative of x cubed is 3x squared. Then multiply the results. So we will obtain y prime is equal to 4 cos times x cubed times 3x squared. So simplifying, we will get y prime is equal to 12x squared then cos x cubed. This is the derivative of the second function. Now we consider the third function. So y is equal to 2 cos square root of x. The inner function here is square root of x. So first remember that square root of x can be written as x to the power of 1/2. So differentiate the cosine function first. So the derivative of cos u is negative sine u. So we obtain y prime is equal to 2 times the quantity of negative sine times square root of x. Next is differentiate the inner function. The derivative of x to the power of 1/2 is 1 over 2 square root of x. Then multiply them together. So we will obtain y prime is equal to 2 times the quantity of negative sine times square root of x times the quantity of 1 over 2 square root of x. The two cancels with the denominator. So we get y prime is equal to negative sine times square root of x over square root of x. So that is the final derivative. So the fourth function is y is equal to 2 sine cube 2x. This means y is equal to 2 times the quantity of sine times 2x to the third degree. So we again apply the chain rule. So the first step is again differentiate the outer power, which is the derivative of u cubed is 3u squared. So we get y prime is equal to 2 times 3 times the quantity of sine 2x raised to the second power. Then differentiate the inner sine function. So the derivative of sine 2x is cos 2x times 2 by multiplying everything. So we will obtain y prime is equal to 2 times 3 times the quantity of sine squared 2x times cos 2x times 2. Now simplify it. Our 2 times 3 times 2 is equal to 12. So the final derivative becomes y prime is equal to 12 sine squared times 12 sine squared 2x and cos 2x. Next, we have y is equal to the quantity of 3 cos 2x plus 1 to the fourth power. Here, the entire expression inside the parenthesis is the inner function. So the first step is to differentiate the power. The derivative of u to the fourth power is simply 4u cubed. So we write y prime is equal to 4 times the quantity of 3 cos 2x plus 1 to the third power. Then differentiate the inside expression. So the derivative of 3 cos 2x is 3 times the quantity of negative sine 2x times 2. This simplifies to negative 6 sine 2x. The next step is to multiply everything together. So y prime is equal to 4 times the quantity of 3 cos 2x plus 1 raised to the third degree times the quantity of negative 6 sine 2x. So simplify the constant. Now we will in simplifying the constant, we have 4 times negative 6 is equal to negative 24. So the final derivative of this function is y is equal to negative 24 sine 2x times the quantity of 3 cos 2x plus 1 raised to the third degree. So we have now the problem 6, or which is y is equal to the square root of the quantity of 1 minus 2 cos x. First, again, if we encounter this kind of problem, we need to rewrite it. So when we write this square root as an exponent or exponential form, we can obtain y is equal to the quantity of 1 minus 2 cos x raised to the power of 1/2. So in differentiating the power, the derivative of u to the power of 1/2 is 1/2 u raised to the power of negative 1/2. Since you are going to subtract the power to 1. So we have now y prime is equal to 1/2 times the quantity of 1 minus 2 cos x raised to the power of negative 1/2. So our step 2 is to differentiate the inner expression. So the derivative of negative 2 cos x is 2 sin x. Next is to multiply them. So y prime is equal to 1/2 times the quantity of 1 minus 2 cos x raised to the power of negative 1/2 times the quantity of 2 sin x. The 2 cancels with 1/2. So we obtain y prime is equal to sin x over the square root of the quantity 1 minus 2 cos x. So now finally we have y minus the quantity of 2 sin 3x minus 3 cos 2x to the third degree. So differentiate the outer power. The derivative of u cubed is 3u squared. So we write y prime is equal to 3 times the quantity of 2 sin 3x minus 3 cos 2x squared. So our next step is to differentiate the inner expression. So the derivative of 2 sin 3x is simply 2. So 2 times the quantity of 3 cos 3x is equal to 6 cos 3x. So the derivative of negative 3 cos 2x is negative 3 times the quantity of negative sin 2x times 2 is equal to 6 sine 2x. So our step 3 is to combine them. So we will combine those expressions na gikan sa derivative. No? So we 6 cos 3x plus 6 sine 2x. So we should multiply them, the combined terms. So now we will have y prime is equal to 3 times the quantity of 2 sine 3x minus 3 cos 2x squared times the quantity of 6 cos 3x plus 6 sine 2x. So factor out 6. So our final derivative would be y prime is equal to 8 times the quantity of 2 sine 3x minus 3 cos 2x squared times cos 3x plus sine 2x. So that's all, and in this video we actually differentiated 7 trigonometric functions using the chain rule. So the key idea is always two. First is identify the outer function, second is differentiate the outer function, and then third is multiply by the derivative of the inner function. This technique is extremely useful when dealing with composite functions, especially in trigonometric calculus. I hope this tutorial helped you understand how to apply the chain rule step by step, and thank you for watching.